Russia, but the first nuclear reactor accident actually happened in Canada with the NRX reactor accident at Chalk River Laboratories on Chalk River.
On July 22, 1947, the National Research Experimental, or NRX, nuclear reactor became operational. It was Canada's first large-scale nuclear reactor and played a huge role in the development of the CANDU nuclear reactor. The reactor was used for the testing of fuels and materials. It was also used for nuclear physics research and played a crucial role in the Canadian nuclear power program. After 250,000 hours of service, the NRX reactor was decommissioned.
Chalk River, a town near Ottawa, was chosen as a site for the nuclear facility due to its location next to the Ottawa River. The Ottawa River was important because it provided easy access for cooling water for the nuclear reactor.
Here is a diagram of the NRX reactor. The NRX reactor is 34 feet long and is 30 feet above the main floor. Here in the center is the Candria, which is made of aluminum and holds 3,300 imperial gallons, or 18 tons of heavy water. Heavy water is used as a moderator and a coolant. Reactors such as this one use the heavy water as a moderator of neutrons so they can use uranium fuel. Here, there are 176 assemblies of fuel rods, each 32 feet long and containing 120 pounds of natural uranium. There are also 12 shutoff rods filled with boron carbide. And here, there is one control rod, which is used to control the reactions. Here are 4 concrete shields, which help reduce radiation to safe levels. Just under the concrete shields are 3 steel cooling shields, which help get heat down. Under the calandria are 4 of the same steel cooling shields and 1 lead masonite shield.
Due to an operator error, 3 rods were raised, and although they tried to fix this problem by dropping the rods back down, the rods didn't fall fully back into place. Unaware of this, an assistant was asked to raise 4 rods from the reactor. In doing this, the assistant accidentally didn't maintain proper air pressure at the heads of the shutoff rods. With 7 rods out of the core, the reactor rose quickly above critical. When they tried to fix this problem, they couldn't because the air that moved the shutoff rods had been released and only 1 rod fell back into place. The power continued to rise. At 20 megawatts, the rate increased even more. This was likely due to the cooling water being pulled out from around the rods. The heavy water was then drained from the Candria, and the power level fell after reaching 80 megawatts. That's enough power to power all the homes in Bay St. Louis, Gulfport, and Biloxi combined.
Cooling water, air, heavy water, and radioactive fuel rod material mixed and flooded the basement of the reactor.
Due to the reactor being flooded with radioactive material, the cleanup was very strenuous. The cleanup was led by future President Jimmy Carter. At the time, Jimmy Carter was the Navy lieutenant. Him and 12 Navy personnel led the decontamination of the reactor.
The NRX reactor was not designed for major repairs complicated by radioactivity. The reactor's initial design was focused on research and development, not long-term, high-power operation, and it lacked features that would have made major repairs feasible. Additionally, the presence of significant amounts of radioactive material in the reactor core, particularly in the exposed uranium, presented a major hurdle for any repair attempt. Unable for the reactor to be restored, cooling water had to be kept on highly irritated rods. 100,000 gallons of water in the basement that was contaminated with radioactive material had to be pumped into holding tanks where they had to bring these tanks of contaminated water to a disposable location. The process for removing and disposing of the calandria was very rigorous in order to remove and dispose of the calandria from the reactor. For that, they had to remove the bottom water heater. They had to lower the masonite shield and remove it through the basement while decontamination processes were going on. Then, the calandria was flushed with a high-pressure water hose into a tray. There was rigorous training for this. 70 men were briefed with a scale model and rehearsed the procedure multiple times. They used a steel dummy of the same diameter and weight as the calandria and used this as the practice run.